Right, so in this video, we're going to be looking at or using all the knowledge we gained from vectors to solve vector problems dealing with shapes and ratios. So in this case here, we have OABC, which is a square. M is the midpoint of OA, and Q divides BC in the ratio 1 to 3. If OA is A, so this is A, and OC is C, express OP in terms of A and C. So first things first, we're given a couple of information. So M is the midpoint, so the ratio is 1 to 1. And Q divides BC in the ratio 1 to 3. So we need to be aware of these information before we start. So first things first, we need to find O to P. So we always want to find a root first. How do we start at O, get to P? Well, I can say I can go O to A, and then from A, I can go A to P. But the problem is we don't know where P is in positioning in the line A to C. So what I'm going to say instead is I'm going to say, well, A to P is actually going to be some ratio, some constant value, let's call it X, of A to C. Because I don't know where it is in relative, right? But I can say it's just going to be a factor along the way, right? So therefore I can say it's going to be X times A to C is just minus A plus C. So therefore O to P is going to be O to A, which is just A, plus some X times minus A plus C like this. Okay, this is the technical answer. I'm just going to group the A's and C's together. So A, I'll have 1 minus X actually. And then we'll have just XC on its own. Right, in B, show that P divides AC in the ratio 2 to 3. So they're saying this is now 2 and 3. That's what we have to show, basically. So the good thing about vectors is, if you start and end, right, it doesn't matter what route you take, it's going to be the same. Okay, so O to P, I can find another route which is starting from O to P, which is different to the first route. So maybe I can say it's O to C. From C, I can say C to Q, and then I can go Q to C like this, or Q to P, sorry. That way I end up starting at O and end up at P, but it's a different route, but they're going to be the same as the first part A, because it doesn't. That's the good thing about vectors. Right, things we don't know, well, C to Q, we know C to Q, we're given the ratios 1 to 3, right? So that's going to be 3 over 4 of C to B. Okay, so 3 over 4 is just 3 over 4 A, but C to B is the same thing as O to A, right? Because they're parallel to each other. Now it's Q to P, which is a bit problematic, because Q to P, we don't know where P is along the line Q to M, right? So I'm going to say it's going to be some other letter, let's get capital Y of Q to M. And so Q to M I do know, so I can say it's going to be Y times Q to M. I can say Q to C plus C to O plus O to M. So just following the root. So Q to C is minus 3 over 4 A, C to O is minus C, and O to M, because M is halfway up, it's going to be half of A. Okay, so now I know this, I can find OP. So O to P is going to be O to C, which is C, plus C to Q, which is this term here, 3 over 4A, plus Q to P, which is this term here, Y times minus 3 over 4A minus C plus half A, like this. Okay, so I have one route getting started from O to P here, and I have another route starting O to P here. And as I said, even though they're complete different routes, they're going to be the same vector, so I'm going to equate them together. But before that, I'm just going to simplify this second term first a bit. So I have, how many C's do we have? Well, C, 1 minus Y plus A, what do we have here? 3 over 4 plus minus a quarter A, like this. So a quarter Y. Okay, and as I said, this term, it has to be equal to this term here. So I'm going to equate them together. So I'm going to say A1 minus X plus XC. From here now, I'm going to look at each coefficient. So the A coefficient and the C coefficient. So looking at the A ones, I'll have A1 minus X on the left-hand side, and that's equal to A 3 over 4 minus 1 over 4Y. The C coefficients, I'll have XC on the left-hand side, and that's equal to C1 minus Y on the right-hand side. So I have two unknowns and two equations, which means I can find what X and C are. X and Y are, sorry. So X is 1 minus Y, which I'm going to plug into here. So I get 1 minus Y is equal to 3 over 4 minus 1 over 4Y. So we'll get Y is equal to 3 over 4 minus 1 over 4Y. 5 over 4Y is equal to 3 over 4. So Y is going to be 3 over 5, like this. I'm going to plug it back into here to find my X. So X will get 2 over 5. Okay, so we basically proven it because what did we say x was in the beginning? Well, x we said was some factor along the way along here. So we said a to p was some x ratio of a to c. And it turns out that x is 2 over 5, which means that this is now 2 and 3, or 2 pixels along the way. So the ratio is going to be 2 to 3. So the main thing I want you to take away from this example is that we find, if we want to prove this kind of stuff, we have to find two completely different roots and equate them together and then find this particular ratio to show that it's like a certain ratio in between that line. But let's try another example here. So in triangle ABC, the position vectors of A, B, C are given like this. Find A to B, A to C, and B to C. So let's find each one first. So A to B direction vector is just, as we said earlier, B minus A. So this is A, B, C here. So B minus A is 4, 3, minus 5, 8, which will give us minus 1, minus 5. And note, we're trying to find the magnitude. So the magnitude of A to B is just the square root of minus 1 squared plus minus 5 squared, which is square root of 26. Same thing for A to C. A to C is C minus A. So it's 7, 6 minus A, which is 5, 8, which will give me 2 minus 2. The magnitude of A to C is just therefore the square root of 2 squared plus minus 2 squared, which is square root of 8. And finally, B to C is going to be C minus B. So C is 7, 6. B is 4, 3. So we'll get 3, 3, which is, and then the magnitude of that, B to C, it's going to be the square root of 3 squared plus 3 squared, which is square root of 18. So we found each magnitude in part A. Determine the size of BAC, ABC as ACB. So in this case, we're going to have to be using the cosine rule. This is a triangle, right, which we've learned earlier. So as I said, it's best to draw it out. So let's just draw a random triangle here. If they haven't given you a drawing, always try and draw the vector out. It's so much easier to visualize. And let's just find one of these. Let's just find BAC. So BAC means we're to find this angle here. And so that's why we are given the lengths, or we're asked to find the magnitudes earlier, right? Because we found the magnitudes as BC is root 18, AC is root 8, and AB is root 26. So using this, I can find this angle A using the cosine rule, right? Because we know three lengths and we're trying to find the angle. So cos A is equal to, or maybe let's just find ABC instead, this one here. So cos ABC is equal to root 18 squared plus root 26 squared minus root 8 squared over 2 times root 26 times root 18, which is equal to ABC, it comes out to 33.7 degrees. So it's incorporating what triangle rules along with the vectors, because we found the magnitudes of each direction vector earlier to find the size of the triangle.